Hello students! Welcome to Grade 10 Science Lesson. And I'm your teacher, Ma'am Marian Soriano. Gases have three main characteristics. They are easy to compress. Gases expand to fill their containers. And they occupy far more space than the liquids or solids from which they form. Let's get to know more about properties of gases in today's lesson. Lesson 1. Properties of gases. All gases can flow like liquids. This means the molecule of gases move independently from each other. Most gases are colorless, like hydrogen, which is a flammable gas. Gas particles will spread about or diffuse in order to fill all the space in any container, such as a bottle or a room. Compared to liquids and solids, gases have a very low density and viscosity. We cannot directly see most gases since they are colorless. However, it is possible to measure their density, mass, volume, temperature, and pressure. Here are the commonly used units for volume, pressure, and temperature. Commonly used units for volume. For the SI unit, we have cubic meter, cubic decimeter, and cubic centimeter. For metric unit, we have liter and milliliter. For the English unit, we have quart and gallon. Please take note of these volume units and their equivalents. Remember that 1 milliliter is equal to 1 cubic centimeter. 1 liter is equal to 1 cubic decimeter. And 1 cubic meter is equal to 1,000 liters. Here are some examples of conversion of volume units. What is 350 liters in cubic meters? Using the equivalents, 1 cubic meters is equal to 1,000 liters. Using the factor label method, the value of 350 liters in cubic meters is equal to 0.35 cubic meters. Let's have another one. What is 935 milliliters into cubic centimeters? This one is very easy. Since 1 milliliters is equal to 1 cubic centimeters, 935 milliliters is simply equal to 935 cubic centimeters, or you just change the unit into cubic centimeter. Commonly used units for pressure. The SI unit or the standard unit for pressure is Pascal. Remember, Pascal is simply Newton per meter squared. For metric unit, we have atmosphere, millimeters of mercury, and centimeters of mercury. And for the English unit, we have torr and pound per square inch or PSI. Here are the pressure units and their equivalents. 1 atmosphere is equal to 760 millimeter of mercury, or equal to 76 centimeters of mercury, or that is equal to 760 torr, or equal to 101,325,000 Pascal, or equal to 14.6956 pound per square inch. Here are some examples of converting pressure units using their equivalents. What is 6.0 torr in Pascal unit? Using the equivalents and factor label method, 6.0 torr is equal to 800 Pascal. Let's have another one. What is 2.0 kilopascal in atmosphere unit? Remember, kilo is a prefix which is equal to 1,000. By moving the decimal point from right to left 3 times, we can convert Pascal into 101.325 kilopascal. Now we can cancel the unit kilopascals. The value of the pressure is 0.02 atmosphere. Temperature units and their equivalents. Remember, 0 degrees Celsius is equal to 273.15 Kelvin, or 0 degrees Celsius is equal to 32 degrees Fahrenheit. These are the formula that you can use to convert the units of temperature. For converting degree Fahrenheit in degree Celsius, converting degree Celsius in degree Fahrenheit, and for converting degree Celsius into Kelvin, you just add 273.15 Kelvin. Remember, Kelvin is the standard unit of temperature. In dealing with gas law problems, always make sure the unit of temperature is in Kelvin. Examples: what is 38 degrees Celsius in Kelvin? You just simply add 273.15 Kelvin. The value of temperature is 311.15 Kelvin. Here is another one. What is 40 degrees Fahrenheit in degrees Celsius? Using the conversion formula, the value of the temperature is 4 degrees Celsius. What will be the behavior of gases at standard temperature and pressure? According to ideal gas law, standard condition of temperature and pressure is known as STP. There are two things you should know about this. First, the universal value of STP is 1.0 atmosphere per pressure and 0 degrees Celsius for temperature. Observe the properties of the three gases, helium, nitrogen, and methane, at standard temperature and pressure. The value of the pressure and temperature of the three gases are the same. And in STP, 1 mole of gas will take up 22.4 liters of the volume of the container. This idea is very important to understand better the behavior of gases. The properties and behavior of gases can be explained further by kinetic molecular theory. The kinetic molecular theory of gases comes from observations that scientists made about gases to explain their macroscopic properties. The following are the basic assumptions of the kinetic molecular theory. First, the volume occupied by the individual particles of a gas is negligible compared to the volume of the gas itself. Second, the particles of an ideal gas exert no attractive forces on each other or on their surroundings. Next, gas particles are in a constant state of random motion and move in straight lines until they collide with another body. Moreover, the collisions exhibited by gas particles are completely elastic. When two molecules collide, total kinetic energy is conserved. And lastly, the average kinetic energy of gas molecules is directly proportional to absolute temperature only. This implies that all molecular motion ceases if the temperature is reduced to absolute zero. The kinetic molecular theory can be used to explain gas laws such as Boyle's law and Charles' law. These gas laws will help you understand the behavior of gases at certain conditions, which will be discussed in the next video lessons. I hope you learned and enjoyed our lesson. This is Marian Soriano. See you in the next lesson.